Good afternoon. We are Ana Sanchez and Ana Maria Montiel from the Estudio Ataria group, and we're going to talk about using STO products in a specific case study. In a building in Madrid, in Calle Duquesa de Castellón, it has 8 homes in 4 floors. I'm going to focus first of all explaining the project. Secondly, we'll talk a little bit more about the thermal envelope, the shell, airtightness. First of all, let's talk about the project. Estudio Ataria creates the design and the total development of the project. And as we wanted to do sustainable building, when we heard about Passive House, we tried to implement it in the buildings. And we have managed to do it in this third promotion on Duquesa de Castellón Street. So we're talking about a building, like we've said, with 8 homes on 4 floors, with continuous thermal envelope, but there is airtightness per home, high quality glazing and framework, heat recovery system, climate control system with radiant ceilings, and centralized aerothermal technology. The thermal envelope. The building is divided into 2 blocks, which are linked by a communication element. You have a square one, where the SAT has a width of 10 centimeters, and in the narrower one, 14. This means how important shape is when we're talking about the envelope. The building has a concrete structure, and we also have wooden walls, and on both elements we've used continuous SAT insulation. The timber wall has a width of 15 millimeters, and outside there is a plinth of timber particles. Then we also have insulation of lambda 33 cellulose, and with a mesh that allows us to put together the inner and outer layers. Indoors we have a double plate of paint and plaster. And over this skin that can be found in the concrete structure, we've put an SAT insulation of EPS of the STO Classic Co-Lambda 033 and fasteners of Lambda 0031. Look at the different SAT components on the timber wall. We've put there an adhesive agent, and then the SAT of 10 or 14 centimeters, like we said before, and a mortar base and structure that allows us later on to add the finishing touch, which in our case has been done with mortar. For a perfect finish, we need to use different elements. In this case, we can see the border mesh that makes a separation between the mortar and the framework. And also to avoid moisture due to capillarity on the base both of the balconies as well as the contact on the floor, we switched materials, and instead of EPS, well, we have used EPS. And to have a clear profile and not use a plinth, we've used something else, which is the profile border. The only thermal bridge in this envelope are the different tenons, which, as we've said, are practically negligible, but they have a small thermal bridge that has to be calculated with a lambda of 0.001. And we can see here a tenon before you have put the stopper, which is made of the same material as the rest of the envelope. I'm going to talk a little bit about how we've managed to achieve airtightness in the project. As Ana Maria has said, the walls of the facades are made of timber, and on the outside they have a particle board that is airtight, and it's going to be therefore the airtight element of this wall. Once it's been installed, what you do is seal it with the concrete borders, and therefore the homes are airtight. In this project, we've decided to use a reinforcement of airtightness for timber walls, which is a StoGuard coat, which is a liquid membrane that is used as an energy barrier. This liquid barrier or air barrier is a yellow paint that is painted on the timber walls, increasing air tightness but also protecting them during the construction process, protecting the wood against rainfall, for example, before applying the SAT insulation. This liquid membrane also makes it very easy to apply it for the sealing of different joints in different areas, and therefore allows us to solve different problems. And also, in some cases, it's necessary to use the sealing materials that we've seen on the slide. This is the second picture where we can see a joint with a far more complex concrete structure, and we just see how the liquid membrane is applied here to ensure a tight means. The rest of pictures are just an example of how you apply the liquid membrane before putting on the SAT insulation. And finally, we would like to show you a sequence of how you apply all the materials. First of all, the timber walls, where the liquid membrane StoGuard coat is applied. Then we would put the SATE, which is fixed onto the wall with tenons. And as it has this liquid membrane StoGuard coat, we don't have problems with air tightness due to the use of these tenons and their insertion. And finally, we would use the finishing mortar, as we can see on this picture. So to conclude, we would like to say that the thermal envelope of the building is done with an outer layer of SAE, which is used on the upper and lower floor. That SAT insulation has changed a lot, and there are many different accessories that will allow us to solve any problems that may arise in a design project. Air tightness has been reinforced with the StoGuard coat liquid membrane, and thanks to its consistency, it's very easy to paint on any dangerous or complex place in the project, and it protects wood during the construction process. And thanks to this thermal envelope and airtightness of the projects, what we have managed to ensure is that we have homes with a very low energy demand, so that you can lead to energy saving. Thank you very much.